And from 16 pi, we're going to subtract the volume of the paraboloid. Now, to calculate the volume of the paraboloid, we're going to need some integral. So our strategy is going to be to select one disk and give it an infinitesimally small thickness. So first, this area is going to be pi times some radius squared. Now the question is, what is this radius? Well, it's just y, which is equal to the square root of x. Since we've chosen our disk to run perpendicular to the x-axis, we're going to integrate with respect to x. And what are we integrating? The area of this disk. So what we'll have is the integral, and it's important to define your bounds. Since we're integrating with respect to x, our bounds have to be in terms of x. So we start here at x equals 0 and end here at x equals 4, because that is the bounds of our region in terms of x. So from 0 to 4, we are integrating pi times the square root of x squared dx, where dx is the infinitesimally small thickness of our disk. This is dx. Therefore, the volume is equal to the integral from 0 to 4 of pi x dx. We can take the constant pi outside of the integral, and we just have the integral from 0 to 4 of x dx. This becomes pi times 1/2 x squared evaluated from 0 to 4. So what we'll have is pi times 1/2 times 4 squared minus 1/2 times 0 squared. 1/2 times 0 squared is just 0. So then 1/2 times 4 squared is 8, and we're left with just 8 pi. 8 pi being not our final answer. Well, coincidentally it is, but the 8 pi that we just calculated with this integral is actually the volume of the green paraboloid. So to calculate the actual volume of our solid, we take 16 pi minus 8 pi, which just so happens to be 8 pi itself. So 8 pi is the volume of our solid. I'm Christopher from Terra Nova Tutoring. Thank you for watching.